I'm the uh, I'm a dean of this PK21 Pro program. Thank you for your lecturing today and your time. Okay, let's introduce Professor Hugh and Professor Song. They will give you this short intensive courses to you. Okay. Thank you for Professor Hugh and Professor Song. Nice to meet you.
Thank you, Doctor. Nice to meet you.
Yeah.
Thank you, Doctor. It's nice to meet you.
I think that Professor Song is Korean.
Yes, Korean and American. Yeah.
Yes. Professor Hugh is not Korean. You cannot.
Chinese American.
Yeah. Yeah. Okay. Thank you. Thank you for joining our program. Okay. Students, we welcome to the Professor Science today's lecture. Okay. Thank you. Okay. Let's start your schedule. Okay.
Thank you, Professor Hong, for introducing us. So let me briefly introduce Dr. Su, who will give a lecture, a 1-hour lecture about artificial intelligence and machine learning in business today. So he is a professor in Kansas State University in computer science, and he got his PhD in computer science from University of Illinois at Urbana-Champaign. So let's welcome Dr. Su.
Thank you. Can you all hear me?
Yeah.
Okay. Good morning to all of you, and welcome. I'm going to present an introduction to machine learning with applications to management and marketing. I am director of a research lab in artificial intelligence and machine learning that is part of our Center for Artificial Intelligence and Data Science in the College of Engineering. Today, I'm going to start by introducing some broad artificial intelligence concepts, starting with an introduction to artificial intelligence definitions. If I'm speaking too quickly, please let me know. If there are any questions, I will be happy to take them after the lecture. Also, if you would like to type them into the chat, I will be happy to respond to questions. So this lecture is going to focus on the broad definition of AI, or artificial intelligence, which refers to computer systems which are both autonomous, that is, able to perform tasks in complex environments without direct user guidance, and adaptive, meaning able to improve performance by learning from experience. And I'm going to discuss 3 forms of experience that you may be generally familiar with, namely supervised, unsupervised, and reinforcement learning. You may also have seen recommender systems as a use case of artificial intelligence, and I'll talk about the relationship between recommender systems and sentiment analysis and some of the other aspects of data mining. So I'm going to begin with just a basic formal definition of artificial intelligence. These are tied to systemic definitions, namely that artificial intelligence in both narrow and general forms involves models of human cognition and human action. When we talk about human action, we usually use as a standard of evaluation similarity to recorded historical behavior or a capability. In terms of measurement and evaluation of this capability, there's a general division between human-like cognition and action and rational choice. So if we are looking at the economic principle of maximum expected utility, the concept of modeling a machine that is capable of learning, of reasoning, of planning, and of possibly of explanation, of actually articulating the process of decision-making, problem solving, and learning is further refined to include models of utility, models of preference. So in the 1990s and subsequently, there was a lot of AI development that centered around the idea of modeling functions that require intelligence when performed by people. And what we see today in terms of technological advances includes a lot of things that people currently do better. So if humans are better at automatic speech recognition or operating a motor vehicle, the idea of developing a self-driving car or a automated assistant that can answer questions is measured against human competitive performance. At the same time, computational models of mental faculties have also been central to the definition of AI since the 1980s and since the emergence of AI as a field of learning and research in the 1950s. So computations that make it possible to perceive, reason, and act include also this idea of rational action and choice of action. So this is a branch of computer science that's more tied to automation, as we see being very prevalent. So the generic intelligent agent model involves creating an internal model of the state of the world. And if we just want to define the ability to reason about the state of the world using perception, using observations from the world, predictions about the next state of the world, and what actions, what the results and consequences of actions are in terms of expected reward, then we can develop a very general model of an intelligent agent that subsumes or overarches the concepts of a reflex agent, such as a Roomba or a very simple robotic vacuum, a very simple type of automation, all the way to utility-based reasoning and intelligent systems that use deep learning, explainable AI, and very complex models or large models. And I do want to distinguish between complex models and models that have semantic depth. So a large language model may have great complexity in terms of the large data sets or corpora that they're trained on, but not necessarily semantic depth. Are there any questions before I continue? Okay, if you have questions, please feel free to write them anytime. What I'm going to focus on in this lecture is on learning representation and learning to plan and reason. AI is informed by probabilistic methods, by methods from modeling of human cognition, what we call cognitive psychology or neuropsychology, which includes models of how brains, both human and other animal brains, reason, perceive, and communicate. The formal computational models for convergence of learning, the sample complexity of learning, and just generally modeling the computational complexity of learning, methods for actually optimizing the process of learning, including hyperparameters, which are very much at the forefront of deep learning right now, and then economic applications, which you may have heard of under the general title of AI for good or AI for social good. So I'm going to talk a little bit about citizen data science and how this helps us to collect data, how game and utility theory and decision models inform some of these, and how this also is informed by models of cognitive models that are actually neurological, that deal with or impinge on ethics of artificial intelligence and considerations of impact on human benefit and beneficence to AI. philosophical concepts, such as the ability to restrict the complexity of a model based on preference for simple and understandable and explainable hypotheses, or those that admit formal reasoning, and methods from data science and analytics, which I'm also going to emphasize in this talk. So I'm going to present the broadly known species of machine learning that are generally called supervised, unsupervised, and reinforcement. And I've used some diagrams that I've cited from other sources. This one is a Medium article that is just showing how data science lives at the intersection of computer science, mathematics, statistics, and specific business domains. And if we look at that overlap as being the mutual intersection of machine learning, software engineering, and research methods that are formal and theoretical. Formal in terms of deriving mathematical models and deriving statistical sampling methods and modeling methods. So in terms of how this is applied, machine learning is a subset, a strict subset of artificial intelligence. That does not include reasoning from human elicited models, or models that are elicited from human beings, natural language that is produced by humans and recorded, or planning that is based on an action space and a policy space that is pre-programmed. Machine learning consists of methods that may improve our ability to reason, to communicate, and to plan, but do so